Hello everyone, myself Sridhar and I am from Computer Science and Engineering Department. And for the complex engineering problem projects, for subject design and analysis of algorithm, my topic is about the championship retention probability in chess. Here we can see the abstract of the project. This project analyzes which is basically the project which analyzes the probability of the current chess champion retaining their title against a challenger. Here we use things such as we're using the probability theories and the statistical modeling. We evaluate how factors such as the player strengths, match format, and draw probability influence the likelihood of a championship retention. The study model chess matches as sequence of independent games and applies binomial probability concepts to compute outcomes. This is basically the abstract of the project, which basically uses the probability and all to know about the basic detailing of the chess championship, which that they can retain or not. Here, the introduction for the project. Chess championships, like a World Chess Championship, are typically played as a series of games between a champion and a challenger. And the winner is determined based on the total points accumulated. This project aims to mathematically model winning probability of each game, draw probability, and overall match winning probabilities. Here we can see it's basically the introduction where the championship can happen anywhere and happen in a process such as a series of games between the champion and the challenger. And also the winner is determined based on the total points accumulated. And this project basically aims the mathematical model, winning probability of each game and the draw probability and the overall match probability, winning probability. And these all things plays a vital. And then going to the problem statement for the project. Here the problem statement to determine the probability that a reigning champion retains the title in a multi-game chess match given. Here the probability of winning a single game, probability of losing, probability of draw, and the number of games in a match. And this we can see here the probability of probably that the champion winning the match, where the probability of winning the single game, the probability of losing, the probability of draw, and the number of games in a match. And then we are going for the objectives where we have to do such as like model chess matches using probability theory and analyze impacts of draw heavy nature of chess. Then we are going to the computer retention probability and also comparing the different match formats. These are all the objectives we are having, such as modeling the chess matches using the probability theory. And then we are going with analyzing the impact of the draw heavy matches and then computing the retention probability and then going to the towards comparing different match formats. Then here is a methodology we want to discuss to compute this project where assumptions are each game is independent and also champion has a probability which are like we are indicating the probability such as a P as a win probability and the Q as a lose and the D is a draw, where all this probability equal to one. As we know, sum of all the probabilities must be equal to the one. So P plus Q plus D equal to one. Then the match format. For example, we are taking of match format. We're having a 12 game match. Win points is 1 point. If we win, we get 1 point. If we the match is drawn, we get a what do you call the match get drawn. It's a 0.5 points, and then first to 6.5 points to win. I mean, the who get the 6.5 will going to win the match. Uh, then we are having your mathematical model where we use binomial distribution. The formula is basically the p of x equal to k, where nk and p power k and 1 minus p n power k, n power n minus k. This is a formula we are going to use, but since draw exists, we modify scoring, which is like total score equal to win plus zero point 0.5 into the draws, as we are giving the probability that the draw for a draw we give the points such as 0.5. Then going towards we are computing the probability score, and then The score championship greater than 6.5, then going to, it is in champion. And then we are going towards the algorithm steps. Here, the algorithm steps, we are giving the inputs such as the number of games, win probability, loss probability, draw probability, number of simulations, and also initializing the champion wins with 0. Then we are repeating for n simulations. We are get like set score equal to 0. Firstly, the first step is like for any simulation, we are setting the score as 0 for each game from 1 to n. Generate random number like r between 0 and 1. Then if r is less than p, champion wins the score plus equal to 1. Else, if r is less than p plus d, draw score equal to 0.5, then else lose the score equal to be 0. This is basically the thing. And after in games, if a score required points score is less greater than equal to required points, then the example 6.5, the champion wins, and the here we're going to win the thing. And the compute probability equal to champion wins by n. I mean, like the n is a number of simulation, or the champion wins. We'll get the we'll get the system. Does the championship is retained or not? Uh, and then we are going towards pseudocode. That's basically the pseudocode you're having. We're giving the input n, which is a number of simulation. P is the probability of win. Q is the probability of lose, and D is the probability of draw, and n is the number of simulation. And then champion wins equal to 0, initializing the champion wins with 0. For I equal to 1 to n, in simulation, score equal to be 0. For j equal to 1 to n, where r will be random of 0 or 1. And if r is less than p, then the probability, the score will be score plus 1. If else if r is less than p plus d, score equal to score plus 0.5, else the score equal to score plus 0, where if the score is 6.5, the champion wins, and the equal to champion wins plus 1, probability equal to champion wins by n. Then you're printing the probability, and this is all about the thing. Then analysis, here is an analysis, example values, p equal to 0.325, if the champion wins, we get the probability is 0.325, if the losing probability is 0.25, and the draw probability is 0.4. Here are the most important analysis we are having, that if a champion wins, the probability is 0.35, the losing probability is 0.25, and the drawing probability is 0.4. And also having some observations. Higher draw probability favors the champion. Long matches reduce randomness. Small advantage per game compounds over series. These are the observations we have made, like such as higher probability favors the champion. Draw probability, mostly the draw probability is more. Then the longer matches reduces the randomness, and also the advantages for game compounds over the series. Here are the results. You can see the champion has higher redemption probability, even with a slight skill advantage. Like draw acts as a stabilizing factor. Probability increases with the match length. And then we are going for the things such as a conclusion. Here's a conclusion for the project, where the project concludes that the championship redemption in chess is strongly influenced by the factors, or by the following factors. They are like individual game probabilities, match length, draw efficient frequency. Even a small advantage significantly increase retention probability over multiple games. Here is some of the things. The most important things are individual game probabilities, match lengths, and draw frequencies. And this is how we can calculate the championship retention in a chess game. And this is most important. And here are some of the references, such as fight rules, probability theory textbooks, and also the chess match statistics. And I want to say that's all about the chess championship retention, where this chess championship retention is basically depend upon the probabilities of the draw matches, and the probability of the and the duration of the matches. The duration of the match is huge, such that randomness increases, which where you cannot accurately decide what is going to happen, and it does the championship is retained or not. So these all factors plays a crucial role in designing this thing and this project is basically depending on all this stuff, which is like the championship retention, and this is all about the championship in chess. And thank you.